So our technology is getting better and better, but sometimes human eyes and human beings in general are better than the programs we use to try to discover things or figure stuff out. That being said, a mislabeled space object just turned out to be the most Earth-like exoplanet yet. Now, I like how they say mislabeled. If they only knew that young stars are exoplanets, that exoplanets are old stars. If they just changed that one label, they would totally get everything. But it's never going to happen. I don't think it's going to happen in my lifetime, but one could hope. Hi, Celeste. This object called Kepler-1649c orbits a small red dwarf star within the system's habitable zone, which is the external habitable zone of the red dwarf. The actual habitable zone, we don't know if it actually has one inside the planet or the highly evolved star. We don't know its atmospheric composition. We don't know how fast it's spinning. It could be tidally locked in a dead world like Venus. Or Venus isn't tidally locked, but it's a dead world. It's extremely old. It could be just like Venus and have a thick CO2 atmosphere. We don't know. But it's definitely exciting to actually have found an object that was mislabeled what they call a false positive by the Kepler programs, the computer programs. So essentially, Kepler 1649 is the main red dwarf. That would be about right here where that red star is. And then 1649 Charlie is somewhere down here. Or, actually, wait, down there. Or it could be like way the heck over here. We don't know how old it is. It could be about the same size as Earth, which is 1.06 times the mass of Earth. But we don't really know how old it really is. It could be from maybe 2 billion years old all the way up to trillions of years old. We don't know. The gyrochronology paper that I've written places the importance of the Williams number, which is its total axial angular momentum. If it's around 1,000, Earth is 706. If it's about 1,000, then chances are likely it's hosting life. And that life is walking around on the surface. Which means it could be a young Earth. Cross your fingers. That being said, it could have lots of fish, could have oceans. You don't know. That would be really freaking sweet, to be honest with you, but we don't really know that yet. Essentially, though, the exoplanet false positive regime that the Kepler scientists have adopted basically means you have 4 different scenarios. As an example, this is the scenario they're looking for. It's a young hot star and then a very old star, what they label as planet, transiting. And this is what they're looking for. This is a positive. What they consider to be a false positive is a brown dwarf stage star around a younger, hotter host, a binary system of stars, which would give a dip in the light curve because this object is orbiting around, or a mixed system. So you have a set of stars, young stars, and then you have a brown dwarf around the other smaller one. And they consider these 3 to be false positive. And this is the only true discovery in their eyes. But for the people who know about stellar metamorphosis, the false positives, they don't exist. All the objects that they're observing are young Earths. The vast majority of them are young Earths. They just give them different labels called brown dwarf or red dwarf or M star or what have you. If they just knew that, then they could go back to their data and then use statistical analysis to gather entire populations of what it is they're looking at, and then they could draw meaningful diagrams similar to this. Now, I know this is the obligatory stellar metamorphosis diagram, but this is going to evolve considerably. I'm sure Baz is probably looking forward to drawing up those. But Anyways, long story short, the Kepler team back in 2013 labeled that Earth-sized object as being a false positive. They went back to the data through the Kepler working group for false positives and brought it up and said, well, this is the object. It's an Earth-sized object. That the computer program was mistaken. But at the same time, the Kepler scientists are still mistaken, even in 2020. And let me go ahead and read the paper out, the abstract, and I'll do a little bit of translation for you guys. It says here, a habitable zone, Earth-sized planet rescued from false positive status. Two things. The habitable zone is a double habitable zone. It has to have a double habitable zone. You have to have the object orbiting in the external habitable zone of a much hotter, younger star, or you don't. You actually don't need that, but it can help. That's the way Earth is situated right now. Or you could have a internal habitable zone where the atmosphere is really thick and it keeps the internal regions near the surface warm, where life can still pop up. It doesn't even need to orbit a hotter host. But astronomers are not going to talk about that because it's really, to them, it's hypothetical, but we all know better. 2, Earth-sized planet. It should be Earth-staged planet or similar to Earth-staged planet. They don't look at it as being under a time constraint. They look at it from a size constraint. So when the astronomers, when they look out with their telescopes and they measure the masses, they put priority on masses. They classify on masses. This is big, this is medium, this is small, this is extra small. That's completely incorrect way of looking at it. They have to look at it from a time perspective. The really big ones are really young. The medium-sized ones, or the big ones are a little bit older. The medium-sized ones are middle-aged. And as you go down the line, and as they age, they get smaller and smaller and smaller, and they continue disintegrating as they evolve. This is the size is on the x or the y-axis. The size diminishes as the star goes down this line of or this path. So that being said, we know that they don't look at these objects from a evolutionary standpoint or a metamorphic standpoint, if you will. They look at it from it's the size it is now, and then that's the way it's always been, and it didn't have a vast, complex history that we know of, but they actually do know of objects that have deeper, richer histories because they have found objects that they call still the false positives, which are the much larger objects. And if they would just kind of pull their head out of the sand and realize all their false positives are just younger systems, they would understand what all this means. But instead, I guess they just wanted to pluck out the Earth-sized one from there to get the big media attention, and that's, I guess it's pretty effective because I know about it now. I mean, but yeah, that's that. I'll go ahead and put. I don't think I should put anything. Just Google it. Just type in Kepler-1649 Charlie, and you can read about it all day. All right, you guys, take it easy.